And our essential question for this week, we're going to go with how can I use trig ratios to solve triangle problems? How can I use trig ratios to solve triangle problems? And trig is short for trigonometry. Trigonometry, we're going to call it trig this week. That's the study of triangle measures. The study of triangle measures. Trigonometry. Trig. The three trig ratios we will be working with today are, it's the row on your calculator that's 3 above the 7, 8, and 9. It's the sin, cos, tan, which are pronounced or called, we call them sine, cosine, tangent ratios. Sine, cosine, tangent ratios. And if you look at the second function behind each button, you'll see sine raised to the negative 1 power, cosine raised to the negative 1, and tangent raised to the negative 1. We'll be using those next. Okay? Now, sine, cosine, and tangent are all ratios that come from the sides of a right triangle. And there's an acronym, and this acronym is called SOHCAHTOA. SOHCAHTOA. I need everybody to say it with me. Ready? SOHCAHTOA. Very good. One more time. All together now. SOHCAHTOA. Got it? Isn't that fun? Yeah. That doesn't really have anything to do with anything. I just wanted to hear if you would say it. Just kidding. I was kidding about kidding. I'm not kidding. So, the S, the O, and the H. Sine equals opposite side divided by the length of the hypotenuse. The sine of an angle is equal to its opposite side divided by the hypotenuse. You see where the SOH comes from? The S, the O, the H, the S, the O, the H. Cosine of an angle. Cosine of an angle is equal to the adjacent side divided by the length of the hypotenuse. So your ca, your C, your A, and your H, cosine equals adjacent over hypotenuse. The acronym helps you remember the ratios. And finally, tangent of an angle is equal to the adjacent side divided by, wait a minute, no it's not. Dang. Sorry about that. TOA. What's the O stand for? Opposite side divided by the adjacent side. So your T, your O, your TOA, tan equals opposite over adjacent. Everybody good so far? Fun stuff, isn't it? Favorite part of the year. Sine, cosine, tangent. I love it. Almost as much as I love meatloaf. Love meatloaf. It's so good. So now, we're going to draw a right triangle on your paper. Move down a little bit because you need a little bit of room. Triangle ABC. We're going to make angle B the 90. And we're going to label some sides in relation to angles. Now, in a right triangle, what is the side opposite the 90 always called? Good. You better say hypotenuse. The hypotenuse. 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 Now, let's look at angle A. Right here. Angle A. There's two other sides left in this triangle in relation to angle A. Side AB is called adjacent to A. It's next to it, isn't it? Adjacent means next to. So the leg of the triangle that's next to the angle is adjacent to it, which makes side BC opposite of angle A. So in relation to angle A, you've got three sides. You've got a hypotenuse, an opposite side, and an adjacent side. Is everybody clear on those three sides in relation to angle A? Now, let's look at angle B. No, angle C. In relation to angle C, there's still three sides. The hypotenuse is still the hypotenuse. But now, in relation to angle C, side AB is opposite. This is opposite of C. Which makes side BC, what does it make side BC? Adjacent to C. And we don't write sine, cosine, or tangent ratios for the right angle because it's a 90-degree angle and you already know its measure. Good, good? Okay, so now what we're going to do is we are going to take a right triangle with some side lengths and we are going to write sine, cosine, tangent for angles. Let's go with nope, let's change the letters. Let's go with M and N. We are going to write sine, cosine, tangent for angles Now, M and N. So we need a right triangle. Here's M, here's N, here's O. And we're going to go with 13, 12, and 5. Now, if you still have the acronym on that piece of paper, you're fine. But if I can't see the acronym, I always write it down again. The SOHCAHTOA. Make sure you write it down so you refer to it. Do not try to do it off memory. You'll make a mistake. I think the next thing you always want to do is highlight in another color. Take the hypotenuse and make sure that you just call it H, so you don't confuse it with anything else. So now we're going to write sine of M is equal to, sine equals opposite over hypotenuse. What is the side that is opposite angle M? The 5. And what's the hypotenuse equal to? 13. So the sine of angle M equals 5 over 13. And then you take it in your calculator. Now, adjust your calculator to second fix 2. Second fix 2. And then your screen should say 0.00. Now we're going 2 decimal places to the hundredth. And then take your 5 and divide it by 13 and write down your decimal equivalent. Yes. Second fix 2. Green button, period button, the number 2. Got it? Now we're going to write cosine of angle M. Cosine is equal to adjacent over hypotenuse. What is the length of the side adjacent to M? It's 12. And the hypotenuse is still 13, isn't it? So 12 divided by 13, which is 0.92. And now we're going to write the tangent ratio for angle M. Tangent equals opposite over adjacent, the side length opposite of M. I've already done it, that's 5, right? And adjacent to M is the 12. And 5 divided by 12, that's 0.42. Yes? Because when later we're going to be using the sine of angle M to find leg lengths and angle measures. The more decimal places that you have, the more accurate your answer will be. We used to use 4 places. It does become a lot of writing though, but it's more accurate. 0.3 or 0.4 in that case it starts to get real inaccurate. You know, you could potentially do the work and find the measure of M and N and only use the 1 decimal place. Your angles might add up to like 182 or 179 or something like that, and you'd be like, wait, this doesn't make sense. So ideally you use as many as you can, but you don't need to write out 4. Okay? So let's go sine, cosine, tangent of N now. Alright? I gotta move over here. We're gonna go sine of angle N is equal to, sine is equal to opposite over hypotenuse, so opposite of N, the side length opposite of N, that's 12, and the hypotenuse is still 13, isn't it? And now look, you already did the 12 over 13, it's 0.92. Okay, so cosine of M and sine of N are the same. So let's go cosine of n. Cosine of n is equal to, cosine is adjacent over hypotenuse. What's adjacent to n? 5. Good. Hypotenuse is still 13. Already got that. That's 0.38. And then tan of angle n is equal to, opposite over adjacent. Opposite of n is 12. Adjacent to n? Good. And 12 divided by 5 is 2.4. Alright, so there's your sine, cosine, tangent ratios for M, sine, cosine, tangent ratios for angle N. Think you got it? Pretty straightforward? Very good. If you have any confusion at all on the opposite and adjacent stuff, you have to see me now. I've had students go 2 weeks into this and still be wondering, I really don't know why. I really don't know what angle is opposite, or I don't know what side is opposite an angle, and I don't know what the adjacent means. Okay? Make sure you're crystal clear about that today, because going forward you'll be guessing. Your assignment for today is right there in green. Page 573, 16 to 21. Check the odds. Make sure you're checking your odds in the back of the book, and make sure you're checking focus for homework problems.